يا سلام. لكن هلا عنا اليوم homework، حل homework number 7 اللي هو دورة 2007 العادية first session 2007. It's number 7 in the worksheet. Part A, we have the function f of x equal x plus xe minus x, and the domain of definition is r minus infinity plus infinity. Part 1a, calculate limit as x tends plus infinity of f of x. 1a, limit as x tends plus infinity of f of x. We just replace x by plus infinity. At plus infinity x e minus x is 0. هيدي رول بشرح الدرس، يعني نحن أخذنا بشرح الدرس limit as x tends plus infinity x e minus x is 0. We can use it directly and the answer equal plus infinity. And show that the line D of equation y equal x is an asymptote to C at plus infinity. Y equal x, it should be an oblique asymptote. So I have to calculate limit as x tends plus infinity f of x minus yd equal limit as x tends plus infinity. F of x is x plus xe minus x minus yd is x plus x and minus x is 0. Limit as x tends plus infinity. Xe minus x, as we said before, its limit at plus infinity is 0. So, and it's a rule, you can use it directly. So, the line D is an oblique asymptote to C at plus infinity. Part B, calculate limit as x tends minus infinity of f of x. I just have to replace x by minus infinity. يعني this is f of x and I have to replace x by minus infinity. Minus infinity plus minus infinity into exponential of minus infinity. Exponential of plus infinity equal plus infinity. Equal minus infinity times plus infinity minus infinity, and the answer is minus infinity minus infinity minus infinity. You know that minus infinity times plus infinity is minus infinity. When minus infinity plus infinity is if. If you are adding minus infinity with plus infinity, it's an if, determinated form. But minus infinity into plus infinity, if you are multiplying these two, the answer is minus infinity. And limit as x tends minus infinity of f of x over x. Limit as x tends minus infinity of f of x over x equal limit as x tends minus infinity. F of x is x plus xe minus x over x. Of course, we can take x as a common factor. We'll have 1 plus e minus x over x. X with x vanishes, equal limit as x tends minus infinity. 1 plus e minus x. Exponential of minus infinity. Exponential of plus infinity is a plus infinity plus 1 equal plus infinity. Limit as x tends minus infinity of x over x equal plus infinity. So at minus infinity, C admits a vertical asymptotic direction. It means the curve passes its way like it's parallel to the x-axis. Now we have part 2a. Before erasing, let's just write some results of part A, of part 1. First result is we showed that limit as x tends plus infinity of f of x equal plus infinity, and line D oblique asymptote at plus infinity. And we show that limit as x tends minus infinity of f of x equal minus infinity, and at minus infinity we have vertical asymptotic direction. هيدا الريزلت اللي طلع معنا اضطرين نكتبهم لأنه هنحتاجهم التيبل of variation. Now part 2a. Calculate f prime of x. F prime of x, derivative of x is 1. Derivative of x e minus x is in the form u dot v, u dot v, because we have a product between two factors, and its derivative is u prime v plus v prime u. U is x, u prime is 1, v is e minus x, v prime is minus e minus x. U prime v, so it's 1 times e minus x, plus v prime u minus e minus x into x. F prime of x equal 1 plus, I always take exponential as a common factor for the factors that have e minus x or ex as a common factor. So I take e minus x as a common factor, I will have 1 minus x. This is f prime and f double prime. We need to calculate f double prime of x. F double prime is the derivative of f prime. Derivative of 1 is 0. Derivative of this, the product of these two factors, it's also in the form u dot v. This is u and this is v. And derivative of u dot v equal u prime v plus v prime u. U is e minus x, so u prime is minus e minus x. V is 1 minus x, so v prime equal minus 1. U prime v minus e minus x into 1 minus x plus v prime u minus 1 into e minus x. As always, I take exponential as a common factor when I can. طلعنا جوا minus نضربها ب 1 minus x minus 1 equal e minus x into x minus 2, or we can write it x minus 2 to e minus x. Part 2, set up the table of variations of f prime. To set up the table of variation of f prime, we need to study the sign of its derivative. دايما لما نعمل variation لحيلا function نعمل study للsign للدerivative تاعولها. The derivative of f prime is f double prime, so we need to study the sign of f double prime. F double prime, e minus x is always positive, so f double prime takes the same sign as x minus 2, that admits x equal 2 as a root. So the table of variation x vary from minus infinity till plus infinity. خلينا نغير الكلر لأنه بشع. x vary from minus infinity till plus infinity. We need to study the sign of f double prime to deduce the variations of f. F double prime admits x equal 2 as a root. X minus 2 is a first degree binomial, admits 2 as a root opposite. بعدين same. طبعا نعرف study للsign للfirst degree before the root opposite sign as a, after the root same sign as a. ليش؟ لأنه x minus 2 is a binomial of the first degree. Minus it means decreasing, plus it means increasing. Minus infinity, we didn't calculate f prime, limit of f prime. I don't think we have to anyway. F prime of 2, we need to calculate f prime of 2. So in f prime we have to substitute x by 2. Let's just use the calculator. F prime of 2, it's 1 plus exponential of minus 2 into 1 minus 2. And the answer equals 0.86. So this is the table of variation of f prime, and deduce that f prime is always positive. نحلها هون. f prime of x is always greater or equal to its absolute minimum. So f prime of x is always greater or equal to absolute minimum, it's 0.86, which is greater than 0. So by transitivity, f prime of x is greater than 0. This is what we have to deduce. F prime is always greater than its minimum 0.86, which is greater than 0, so f prime is greater than 0. Part C, show that f double prime admits an inflection point. Not f double prime, f or C. Show that the curve C has a point of inflection. To study the concavity of a function or to find the inflection point, we have to study the sign of f double prime. And we already did study the sign of f double prime. هي هون يعني between x vary from minus infinity till plus infinity, f double prime vanishes at x equal to and change its sign. So at x equal to, f double prime of x vanishes and change its sign. So the point I of abscissa 2 and ordinate f of 2 is an inflection point. Okay, f of 2 we have to replace x by 2 in f. أنا نعمل replace ل x by 2 in f. F of 2 equal 2 plus x plus 2 plus 2 exponential of minus 2. نعمل replace بالfunction f. يطلع معي الانسر 2.27. 2.27. Okay. Part B. Set up the table of variations of f. Now we have to set up the table of variation of f. We already know the sign of f prime. So now we can set up the table of variations of f. And this is part D. To set up the table of variation of f, I need firstly to draw a table. As we know, x vary from minus infinity to plus infinity. We found that f prime is always positive. هي عملناها proof هون. So f is always increasing. على minus infinity limit طلع معنا plus infinity. على minus infinity limit طلع معنا minus infinity vertical asymptotic direction. على plus infinity limit is plus infinity oblique asymptote. يعني من vertical asymptotic direction بده يطلع على الأوبليك asymptote. اوكي. هلا هودي بطلت عايزهم لأنه استعملتهم بحيهم، وهودي كمان حطيتهم التيبل اوف فاريشن مع السيريز. هلا البارت 3 determine the coordinates of the point A. Determine the coordinates of the point A to the curve C at which the tangent T is parallel to the line D of equation y equal x. Tangent at A is parallel to the line D. So slope of the tangent equals slope of the line D. Slope of the tangent is always f prime of A or f prime of alpha. Slope of the line D equal 1. f prime حين f prime f prime طلعت معي 1 plus 1 minus x I think equal 1 u prime v as v prime تحت. So 1 minus x equal 1 minus 1 0, so x equal 1. So the point A is f abscissa 1, ordinate f of 1. F of 1 is 1 plus exponential 1 plus exponential of minus 1. نعمل لها replace بالfunction f بيطلع 1.36. This is the point A. Part D this is part 3 كانت. 4. Show that f of x equal 1 has a unique root alpha and alpha. Okay. خلينا نمحن أمحي هون كمان. Again, this is part 4. Show that f of x equal 1 has a unique root alpha. في two methods لنكتبها هيدي. f is continuous and strictly increasing over minus infinity plus infinity. F of 0.65, I just replace x by 0.65, 0.65 plus exponential of minus 0.65, and the answer equal 1.17. We do compare it as 1 is greater than 1. F of 0.66 equal 0.66 plus exponential of minus 0.66 is 1.17. شو إذا كان دي غلط is greater than 1. أكيد هيدي غلط لأنه لازم يكون أصغر من 1. Zero point 65 plus shift exponential of minus 0.65. 0.65 times equal 0.98 and it's less than 1. والتاني 0.66 plus 0.66 times exponential of minus 0.66. And the answer is 1.001. So I did calculate f 0.65, I found it less than 1. F of 0.66, I found it greater than 1. So by using intermediate value theorem of x equal 1 admits a unique solution alpha with alpha is between 0.65 and 0.66. طب كان فينا طبعا نحلها من هذا انترفل، نعملها f of x minus equal to 0 ونعمل comparing مع 0 مش مع 1. Finally part 5 draw D and T and D T and T. T هي tangent وال D هو الأوبليك asymptote. عندي البوينت هلا هو حخليه هون بس حنقول يلي هون عندي البوينت I 2.27 هيدي inflection point قبلها بكون concave downward بعدها بصير concave upward وعندي f of x equal 1 عندها unique solution alpha بين 0.65 و 0.66. اخترت محي من هاي الميلة لأنه بدي أكيد خلي التيبل اوبريشن هو اللي بيخليني أرسم الكيرف. So to do the curve C, I have firstly to draw an orthonormal system. This is an orthonormal system. أول شيء this is the x-axis and كأنه فارق شوي لا this is it was the y-axis then the x-axis. This is the y-axis and this is the x-axis. So x prime over x, y prime over I have to draw the second step to draw the asymptotes and y equal x oblique asymptote. Y equal x, you know, it's the first bisector, 0 0 1 1. Of course you don't have to take points to draw the first bisector, يعني it's known. Okay, هيدا line D is the oblique asymptote. عنا البوينت A1 1.36. After drawing the asymptotes, we have to draw the particular points and the extremes. extremes معنا عنا البوينت I 2.27. هيدي البوينت I is an inflection point. عنا البوينت I نفكر نكبر السكيل شوي. يعني كل 2 boxes 1. هلا هون حيطلع كتير محدود الكيرف، خلص خليه. وعندنا البوينت A1 1.36 هيدي ال I inflection point A 1.36 1.36 هون تقريبا. هون التانجنت is parallel to the line دي، يعني هيدي هي التانجنت يلي أصلا أنا مطلوب مني أرسمها، فأرسمها بهيدا الشكل. أوكي، صار لازم محل I، أنا ما كتير ضيقة بمحلها. هيدي البوينت I هون، وعندي f of x equal 1 عنده unique solution alpha، يعني هيدا اللاين y equal 1 بيقطعوا between alpha between 0.65 and 0.66، يعني هيدي البوينت هون of coordinate 1 هي alpha، يعني الكيرف pass through the point 1 alpha. okay هلا طبعا I can take some particular points like f of 0. f of 0 بيطلع 0، احنا معنا f of x equal x plus e minus x. if we take plus x e minus x, f of 0 بيطلع 0. اوكي، ده كان drawing the curve. لما ال x at minus infinity الكيرف at minus infinity عنا vertical asymptotic direction، شو بدي يعمل؟ بده يطلع increasing. هلا نحنا ما انطلب مننا نعمل relative position between the curve C and the line D. بيقطع الكيرف pass through the point 0 0. اوكي to the، بروح لوين؟ على التانجنت. هيدي التانجنت at this point. from this point بيكون طبعا concave downward، بروح على البوينت I. من البوينت I بغير الكونكافيتي تاعوله وبكمل بكفي at plus infinity على الأوبليك أسمتوت، بصير concave upward. طبعا مثل ما قلت قبل، أنا الرسم على التاتش شوي صعب، مش شوي كتير صعب، فمجرب رسم بأفضل ما يمكن. ماشي، طبعا فينا نشوف الكيرف على الجيوجبرا. قلنا الفانكشن f of x equal x plus x e power minus x. هيدا الكيرف وهيدا اللاين دي of equation y equal x مثل ما نكون شايفين. هيدا شكل الكيرف يطلع هيك، وهيدا زوم ان. طبعا عنا البوينت I of abscissa 2، هيدي inflection point هون. اوكي، وعنا هون ال 1.35 عنا tangent parallel to the line D. هيدا شكل الكيرف كفينا. هلا خلينا نكفي السؤال. Part 6. Calculate the area of in centimeters square of the region bounded by the curve C, the asymptote D, and the two lines x equals 0 and x equals 1. Again, we need to calculate the area between the curve, the peak asymptote, the line x equals 0, which is the y-axis, and x equals 1. هيدا هو. لكن الاريا هتطلع لهيدا الريجن هون. لهيدا الريجن هون. Between the curve C, the line D, and the two lines x equals 0 and x equals 1. Okay. Area equal antiderivative from 0 to 1 of f of x minus yd dx. I don't have here to use absolute value or to multiply by minus لأنه الفانكشن is above the line D، يعني الأنسر أكيد هيطلع positive. Equal antiderivative from 0 to 1 f of x minus yd. We did find it below, it's xe minus x. We didn't find it above before يعني. هيدا x مضروب exponential نعمل integration by parts. هعمل tabular integration u و e minus x. هون نعمل derivative antiderivative derivative antiderivative times plus times minus. So the answer is x times minus xe minus xe minus x minus e minus x between 0 and 1. If you like to take e minus x as a common factor, you can obtain minus x minus 1 between 0 and 1 by replacing x at first by 1 بيطلع معنا minus 1 minus 1 minus 2 e minus 1 minus, then by replacing x by 0 بيطلع معنا minus 1 exponential of 0 is minus 1 and minus 2 exponential of minus 1 minus 1 plus 1 equal 0.729 بس بتأكد من اليونت لأنه إذا سنتيمتر أو 2 سنتيمتر 2 سنتيمتر. لكن this is the area unit square as usual, and in this case unit is 2 centimeter square. 2 square is 4 يعني هيدا الأنسر نضربه ب 4 عملنا 2.90 ما تنسوا 0.729 4 بيطلع 2.916 سنتيمتر سكوير. اوكي هيك بنكون عملنا الاريا. Part B نطرح الكيرف. Part B let f of n of x is a function equal x plus xn e minus x. N is a non-zero, okay, and consider the sequence un equal antiderivative from 0 to 1 fn of x minus x dx. Okay, determine the value of u1. u1 equal antiderivative from 0 to 1 f1 of x. f1 of x يعني f of x يعني f1 of x minus x كلها dx equal antiderivative من 0 لل 1 f1 of x هي x more plus x e minus x يعني هي f of x minus x x e minus x dx. بعدنا كاتبينه هون يطلع الأنسر 0.729 We don't have unit square. We should multiply by any number because it's not an area, it's just an antiderivative, it's just an integral. Part 2. Show that a0 is less than x power minus 1 e minus x less than or equal to 1. This is a bounding, so I have to bound x power n and bound x power and I have to bound e power minus x. يعني أول شيء معنى x belongs to the interval 0 1, then 0 is less than or equal to x less than or equal to 1. بدنا نعمل bounding ل x power n. 0 power n less than or equal to x power n less than or equal to 1 power n is 1. This is a bounding for x power n. بعدين بدي أعمل bounding ل e power minus x. e power minus x يعني كان أول شيء بدي أعمل bounding ل e ل minus x لأنه e power minus x يعني exponential of minus x. هيدي بدي أضربها بماينس. هيدا الباوندينج هضربه بماينس. minus 1 less than minus x less than 0. عملها exponential لأنه exponential هي increasing function. بيطلع معنا exponential of minus 1 less than exponential of minus x less than exponential of 0 هي 1. Two boundings that are positive هيدا وهيدا positive, we can multiply these two boundings. نضربهم ببعض بصير عندي 0 times e power minus 1 0 less than x times e minus x x power n e minus x 1 times 1 1. وهيك بنكون عملنا لها proof. هلا عملنا bounding ل هيدي and deduce that un is bounded. un هي exactly بتطلع antiderivative of x power n e minus x dx between 0 and 1. I did found a bounding for x power minus n e power minus x 1. بس بعمل له integral of 0 dx less than integral of x power n e minus x dx less than or equal to 1 dx. Antiderivative طبعا between 0 and 1. Antiderivative ل0 هي 0. Antiderivative ل x power minus 1 x power n e minus x dx between 0 and 1 هي un. Antiderivative ل1 is x between 0 and 1. By replacing بيطلع معي 0 less than or equal to un by substituting less than 1. And I show that un is bounded. Part 3. Prove that the sequence un is decreasing. But in the sequence do un decreasing. Usually تعمل variations لأي sequence بعمل un plus 1 minus un. يعني antiderivative between 0 and 1. un plus 1 هي x n plus 1 e minus x dx minus un هي 0 from 0 to 1 e power n not e power n x power n e power minus x dx. The two integrals have the same bounds, so I can calculate the difference between them. في اخد x power n e minus x common factor بضل عندي x power 1 minus 1 x power 1 minus 1 dx. هلا x power n positive وال e power minus x positive وال x power x minus 1 هي negative لكن هيدا الانتجرال negative والsequence شو decreasing. هلا over هلا ليش over 0 1 لأنه الانتجرال from 0 to 1 x power n is positive e power minus x is always positive and x is less than 1, so x minus 1 is less than 0. Positive times positive times negative is negative, so un plus 1 minus un is less than 0 and the sequence UN is decreasing. آخر شي and convergent هيدي أسهل شي بس ما ضل لها محل هنكتبها هون ليش sequence UN convergent UN is decreasing and bounded from below by 0 so ليش bounded from below لأنه UN دايما أكبر من 0 هي دايما greater than 0 so UN is convergent طب ليه ما حكينا إنها bounded from above لو إنها increasing كنا حكينا عن bounded from above بس لأنها decreasing إحنا بهمنا bounded from below هيدا هو حل الإكسرسايز الله يعطيكم العافية وشكرا على المتابعة دايما سلام